Hello guys, I'm a teacher Limboka Nsejuga Masame. Welcome to Limboka Physics. We have a question from AF Abbott, number 13 from exercise 23, a reflection and refraction of light in a plane surface. We have given the glass slab of 1 centimeter thick is silvered underneath and rests on the table. Now from the top of that face of the glass there is a speck of dust, and this speck of dust we are required to find the final position of the image, and this final position of the image is due to reflection from the silvered surface and refraction at the top. While I've given the refractive index of 1.5 of that of glass, let us consider the figure below so that we will see how these things happens. We have a speck of dust on the surface of the glass slab, and we have the thickness of this glass slab as equal to object distance u, because remember that this is a silvered surface, and this silvered surface will act as a reflecting surface, and that's why we take this distance from the object to this reflecting surface as u. Now the incident rays that are passing through normal to the edge of the speck of the dust, edge of the object, is reflected back through the same path according to the principle of reversibility of light. We extrapolated the reflected rays backward to the certain points where we will have a second reflections from this is second incidence, that is the yellow in color, then is reflected back to the point M. Then this reflected rays from the greens color, we extended it backwards, we extrapolated it backwards and intersect here where we get the image 1 of this object, and we will have image formed due to reflections to a distance of image v, as from the surface, from the reflected surface to the image formed. And now from the image 1 to surface of this is glass slab is a distance y, as this image 1 will act now as a second object for this final image. Now due to refractions of light, this incident is going to give a refracted rays in a purple color, and you will have a refracted angle as from normal, and you will have incident angle as it is come from this image 1, as this angle is alternate to this angle, and this angle also is alternate to this angle. Now we will consider here the two triangles with a common opposite or M. This is for respective I and R. Okay, after seeing this, now the position of image 2 is a distance x. Let us see how we can solve these questions mathematical. We consider the triangle for first, second, third, the last image, and we consider the triangle for the first image. That is, now we find the sign for from the first for the sign for the incidence. Now it will be equal to opposite to hypotenuse, which is m and I dash, and now we consider the refracted angle. Now you find the sign which is opposite to the mi, which is double 2, that is image 2, which is hypotenuse for as you can see here. Now from the law of from the Snell laws of refraction, we will have the refractive index for glass and sign incidence. Remember, sign incidence is from the media, which is glass, and sign of refracted is from the medium, which is air. Now we multiply with refractive index of air is equal to constant. Now we substitute this incidence, which is O mi for image 1 and OM to the I m for image 2. Now when the observer eyes is very close to the normal, now our im dash is equal to I dash O is equal to its hypotenuse, now is equal to its adjacent, and is equal to y. For incidence, its hypotenuse is close to adjacent and is equal to y, and for respective for refracted, now its hypotenuse is close to its adjacent and is equal to x. Okay, now let us make subject for refractive index is equal to real depth to apparent depth. And now we know that this real depth y is for, as you see, a visual image. The first image is reacted as our second object that will produce the last image. As that depth, we take it as a real depth and apparent depth. Now, but a real depth is equal to object distance plus image distance, as it is from a law of reflections, and also we know from law of reflections the object distance is always equal to image distance, and for here we take y is equal to twice object distance, and so we substitute to the formula and we will have x. We make some subject x is apparent depth, then after make the subject we just substitute to the data. We have twice times a thickness 1 centimeter divided 1.5. Now our position for final image of a speck dust is equal to 1.33 centimeter approximate. Please thank you for watching. Like, share, comment. Don't forget to subscribe this channel for more video like this.